Okay, I'm going to go through some electrostatics for the interim, which is coming up in a couple of days. Hang on, that's not a very good view. Okay, maybe that's a little better. All right, so this is going back to the first unit that we covered this semester, where we talked about the movement of electrons through ways that we made them move. These weren't electrons that were moving in a current flow like we've been talking about more recently. These are electrons that we're making move through some means. Okay. So the first question, you rub a balloon with felt and the balloon becomes negatively charged. What type of charge does the felt have? So the second part of this question, or the one connected to this, asks what type of charging is that? So let's answer that one actually first. When we rub two items together, that type of charging, remember, is called friction. Okay. And so we've got our balloon, we've got our felt. The balloon, when we say it becomes negatively charged, that means it has picked up some extra electrons. Okay. And where did it get those electrons? It got them from the felt. Okay. So the felt has given some of its electrons to the balloon. The net charge of the two is still the same. Okay. We didn't create or destroy any electrons. We just move them around. But what we've done is the balloon has gained electrons, so it's negatively charged. That means the felt has lost some electrons and it's positively charged. Okay. Now we've got a positively charged rod. So let's remind ourselves that means this rod lost some electrons somewhere else. Okay. And it's touched to this neutral sphere. Remember, a neutral sphere is got the same number of protons and electrons if you're neutral. So after the rod touches it, what happens to the sphere? The sphere, it's going to give some electrons to the rod, because those electrons are going to be attracted to this object because it's positively charged. And so both items are going to end up positively charged. So this one had already lost electrons before it arrived and was touched to the sphere. The sphere is going to give some of its electrons to this object. So they're both going to end up positively charged. This type of charging is called conduction. Okay, and remember, with conduction, there's contact. So that's one important thing to remember. Touched to the metal sphere. So that's like a clue word. And with conduction, both items end up the same charge after they interact with each other. What's the best description for the movement of charges that occurs? This is where we think about which particles are moving. So in this case, they're moving from the sphere to the rod, and it's going to be electrons. Okay. Never, never, never do we have protons move. Remember, protons are locked in the nucleus of the atom, and they're not going to move unless there's a nuclear event. So it's always electrons moving. And in this case, because this is lost electrons, they're going to move towards it because they're attracted to it. It's positively charged. If this were negatively charged, if it had excess electrons, then some of those excess would head on over to this neutral sphere once they're touched together, and they both end up being negative. So, okay, now we've got an electroscope. Remember, this is our object we looked at a couple of different ways in class, and it tells us if there's a charge present. So again, we've got a positively charged rod. We bring it near a neutral electroscope, and we want to draw what the charges look like after the rod is brought near it. So note, near it, these are not touching each other, okay? In the case of this event, this is positively charged, so electrons are going to come gather at the top because they like this object, they're attracted to it, and that's going to leave less electrons down the bottom. So my leaves are going to repel because they'll have the same charge, okay? And this is what's called induction. So induction is no contact. And what's the best description for the movement of charges? So the electrons are moving to the top, leaving the leaves positively charged. That's why they move apart from each other, because they're the same charge. And what's the distribution of charges called? This is polarization. Okay, so whenever you have induction, you have a polarization. So you've got a polarization in an object when you have induction. Nothing's transferring between these objects because this isn't touching this object. It's just brought near it. It's just causing movement of the electrons within this object. And they're always going to end up being a polarization, which is a separation of charges. Again, with these choices, protons are never going to move, and we're not going to have electrons jumping from this object to this object. They're not going to do that. They're just going to move within this object in response to this one being brought nearby. Okay, let's see what else we've got. Then two balloons of opposite charge are shown. I don't think my figure is printed out on this page, but so we've got two balloons that are of opposite charge. Somebody's holding them, so in the first part. And then they're released. So I'm holding them and then I let them go, and they attract to each other. So which statement is most accurate in regards to their potential energy? All right. So in the case of my two balloons here, remember potential energy. We've talked about potential energy before last semester. It's like a stored energy. And it's an energy that would convert to an energy of movement eventually. So if I've got two objects that are attracted to each other, they are going to have less potential energy because they want to be near each other. They just want to hang out together. They don't want to move, okay? If they repelled each other and I try to bring them close to each other, they're going to have more and more potential energy because they're going to want to be getting away from each other, okay? So the potential energy is going to decrease. That means it's going to be choice B or C. B says that it decreases because they are attracted to each other, so I like that response. C says it decreases because the force is lower. The force is actually going to go up because it depends on distance. And we'll talk about that in a few minutes when we get to the bottom part of this, which will be, I think, in the next video. But potential energy is different than force. Okay, so we're going to choose B because that is the best description. And I've got this section remaining. I'm going to do it in the next video because this one's gotten almost 10 minutes long. So see you soon.